Okay, welcome back. In this video we're going to learn about transforms. We're going to take an image and we're going to move it around on the screen, and we're going to learn that there's a couple little gotcha moments. Okay, so I've got a blank sketch here, so I'm going to do a OF image. I think that's all I'm going to do in this header file. So I've got an OF image called image. Save, and let's move to the CPP. So okay, before I try to load an image, I have to put the image in my project folder. So my apps, and this one's called transform. So here's this bin. Okay, so right here's my project. This is my projects folder, bin data. This is where we put our image. And today I've got this picture of Buzz Lightyear. We're gonna make Buzz Lightyear flying on the screen. All right. Okay, so image.load. What is this file called? It's a PNG. Buzz.png. Good. Okay, let's try it. Image.draw. I always like to do real simple iterations, make sure that my code works, make sure, if you code a bunch, then you gotta have a bug. It's hard to figure out where that bug came from. So step by step, we get to know what's going. Okay, great, it works. Okay, so you can see that this PNG has a white background, and that's something that it's always nicer if you can get PNGs are nice because they can have transparent backgrounds, and it's always nice when you can find a PNG that does. If you don't, you got to work around it. And in my case, I'm just gonna make a white background just to sort of cheat here. I guess the other way of doing it is just like making the background transparent, like editing in Photoshop. But here we go. Okay, so what I'd like to do is I want to put this in the center of the screen. Now there's some dimensions to this image. We got to deal with, like, how do I put it in the center? For the moment, let's just move it ourselves. Let's go like 100. I don't know how much was it needed? Maybe 100 in here and 200 in the X, something like this. And what I'm going to show you is I'm going to move it to the center, and then I'm going to try to rotate. So yeah, that's a little bit. Okay, so let's do like 100 and 100. Okay, so here's a question. How do I rotate this image? We haven't learned this command yet, but it's not going to come from the image. Like, you don't say image.rotate. We're not going to do, so rotate 90. It has that. That's nice. It doesn't have any other of the other degrees. And the reason is, to rotate an image, we have to, it sounds weird when I say it this way, we have to rotate the space around the image. Okay, OF rotate degrees is always a little nicer to deal with. This is our, by default, it's 2D, and it's kind of nice to deal with just to begin with. So let's try this. So if I did something like 45 degrees, okay, so this is not a 90, it's half of a 90 degree. We're gonna see that it will, in fact, do this rotation of 45, but it's no longer the center. Do you see this? If you took your hands like in the position that it was and try to do this rotate, it's not rotating around the center of the image. It's also, maybe some of you thought of this, you know how images are drawn from the top left point, but it's not rotating around that point either. So that would have been another really good guess there. What it's doing is it's rotating around the origin of the world, which is that top left. Remember 0 pixel, where 0 pixel is? It's rotating around that point. So as it turns out, what we have here is a coordinate system with an origin, and all of these what are called affine transforms. And if you're interested, you can look up this list. Here's the Wikipedia page for this. Affine transforms, you might know them from design software, Photoshop, Illustrator stuff. Like, it's got rotate, translate, scaling. Those are sort of the popular ones. You can do most of what you need to do with those. It's also got shearing, which is, that taking the top and bottom, keeping them parallel but moving them. So I like to think of rotate, translate, scale. Those I can do most of the stuff that I need to do. But to unlock these functions, we need to understand this coordinate system. So as we just figured out here, when we do a rotate, we're rotating around the origin. If we do a translate, we're going to move the origin, right? If you think about it, if I change this to, well, let's comment, just do translate 100, 100. This, you know, think about like when we're transforming the world, we're transforming the objects in the world, right? 'Cause just to bring it back to reality, okay? We're transforming the world, whatever that means. You can see it by how the objects in that world transform. So we've moved the, do you see, like I've got an OF translate 100, 100, and that brought it half of the way to where it is. The other image draw 100, 100 brought it another set of pair of 100s down here. So this point right here is actually the point 200, 200. We've moved 200 in both directions. So these are, what these do is a fairly similar thing. The difference is that the OF translate actually moved the origin. So we can see this. If I do an OF draw circle and put it at the origin 0, 0, 30, and this is going to be just marking the origin, so we can see where is the origin. We do a translate 100, 100. So we would expect to see it, and it would be nice if I did OF set color. We'll make a red circle, 25500. Remember how images will get red if you like leave that red on. So this will be a nice test. So here's my image with a white, circle with a red. This all happens after the translate. So we're going to see where right there. So there's our 100, 100 point. That's our new origin. So if I do a rotate after this translate, it's going to rotate around the origin after the origin has been shifted. So let's see this happen, and then I'm going to also clarify, like, it's going to be a lot easier if okay, so can you imagine where it is now? Can you see it? It's been rotated around that red point. Let's go back here, and just to simplify things, instead of drawing an image at the with this like 100 like translation and whatnot, let's draw the image at the origin. Now this is how I do all of my translations, any of my transforms. Whenever I'm transforming an image, to allow for these rotations and these translations and stuff, and to sort of build, just to ground myself in this coordinate system, draw your image at the origin and use these transforms to move it around and move it into place. And the reason is going to be helpful illustrated here. Let me do this. So what I'd like to do is I'd like to translate to the center as we've sort of done, and then rotate this image based on mouse X. That would be nice. Let's do this. So here I have my translate, rotate mouse, maybe we'll just do mouse X, rotate degrees mouse X. That works, yeah. Okay, so we're going to be rotating around this origin point. We're drawing our image at this origin. Okay, great. So you see this. We've moved our origin. We're still rotating around the origin. We've just moved it, and the image is drawing top left corner at this point that is the origin. This is good. Okay, so what I'm aiming for is to be able to rotate the center of this image so that it rotates like this, kind of like how I would imagine this figure would be rotating. Okay, so there's ways. So let me just backtrack here. And take away this translate. All we have is a rotate, and I think I can get rid of that circle. So let's bring it back, dial it back for a second. Let's reorient ourselves. We are looking at a image that is being rotated around the origin. Okay, this is fine. What I want to do is I want this image to be rotated. So think about it this way. now that we know that we can move that rotation point 100, 100, we can move it anywhere we need to. So in theory, I could move that to the center of the screen. But that doesn't solve our problem about this image is still being rotated around its top left point. So in creative coding software, a lot of these programs have this ability to set the image. In processing in P5, it's set image mode. In open frameworks, it's we have to set the image itself, image.setAnchor, and this is and this approach is also how CSS does it. You set the anchor point, and that anchor point, I like the percent better. You can say 50%, 50%, and that's the middle of the image, and then from then on, all the transforms will happen around that. We can do this real fast. It's just let me do this up in the after we load it. It makes more sense to set all the settings of an image like that. The drawing is just like related to how you're drawing. So so this is great. Okay, so our image is, don't mind the detail that it's not like a fourth of it is only visible at one time. This is actually great. We're rotating around the center of this image. Okay, I wanted to show you a different approach to this though, because it fits with how we're learning this coordinate system. If we were to not use this, it's possible to still draw this image at the center. If we translate the image first, before we do any rotation, if we translate to be like where we're going, and I guess it's helpful to know like the dimensions of this image. So I'm looking at 860 by 418. It might be nice to copy and paste this in here. So normally normally when I work with images, I like to be in control of this aspect ratio, and whenever I'm down here, I'm drawing the width and the height, which by the way are the third and fourth parameters here. But I can just go ahead and stay with this. I'll just use these for now. It's going to make the code a little simpler. Okay, so instead of, remember this is where we would put our 100 100 before. If we're gonna switch to gotta leave that in there. Switch to using these transforms. OF translate. I'm gonna put this just right above it, just because that's where we were using it. So and I'm gonna draw this. I'm going to move it, so I'm moving it to be just like how you saw it a second ago. I'm moving this to be so that the origin, this image is being drawn where the origin is at the center of the image. So half of 430, half of the width, half of the height, negative 209, yeah. And I don't need this color right now. We're not doing anything with that. Keep it simple. So we have a rotate and a translate. Cool. Okay, so this is translated. We're doing our rotation, and then before we do anything, before we draw the image at 0 0, we're translating back half of the image so that this is like now in the center. It's possible that you might have done this backwards like this, and there's going to be that comes up many times. Just to show you what it looks like, it's going to rotate around the top left corner point and then translate back. So do you see this? Okay. Yeah. So this. You can imagine that top left corner is over there. The top left corner point is staying over there, and it's just rotating around that point. So it's doing the correct thing in reverse. Let me show you this is gonna translate. This is gonna bring it back to like 100 100. This is going to like solve our problem entirely. Putting it at the center of the screen, rotating it, and let's do this and just see. Oh great. Oh yeah, it didn't. Okay, this is the 100 100 now, and this makes my math a lot easier now. So this is. I just moved that origin right there, 100 100. I forgot that that's not the center point anymore. The center point is actually the center of the screen, which makes our code a lot easier. OF get width, width there, divided by 2, get height, divided by 2. Okay, yeah, this is good. This is like nice clean code. The only arbitrary numbers we're looking at are these things which relate to the image size. And there we go. Okay, so now we've got our image rotating around the center. Also, I've been looking at it this whole time, but haven't acknowledged it in my brain. That's not white. That background is slightly off white. But that's good. I think it's like, it just helps you like really illustrate that the whole background is like an issue that you're gonna have to worry about. Okay, so what's going on here? Can we just make sure we understand? 3 lines of code. That's all it took, really. But it took a bit to get there. Okay, dial it back. Let's comment as well as help. If I just draw the image at 0, 0, we're drawing top left corner. Top left corner, right? If I change this to be something like to get to the center of the screen, I have to translate it, but remember it's being drawn from the top left corner, so I have to do this like math about like, well, how big is this image already? How much does it need to nudge towards the center? And that's why I was doing like 100, 100, so that gets it like to the center of the screen. Writing it this way is the same as doing OF translate 100, 100. So this would be the same as if this did not exist and that the 100 and 100 were right here. So you want to put the translate before the draw, otherwise it's going to draw first and then translate. Like so hopefully that's going to be a little easier to understand than first challenge to understand. This does not work because it draws the image and then it performs the translate. So our moment has passed, right? So there is an order. The order matters. We have to do our transforms before the image happens. The next challenging detail to understand is, why do we do them in this order? Why this first and then rotate versus like rotate then this? Like what's the difference? And if I'm going to switch this out for, here we are. Let's just do this for now, just to play with this to get a feeling for the order here. So I'm going to move the top left corner to be the center of the screen. Okay, good. Yeah, top left corner is right here. And again, this is now the origin. This is the origin. Everything rotates around this. Everything scales around this. This is the origin. So let's add the rotate before and then after this translate, and just to see the effect, just to really grasp what's going on. OF rotate. I'm just going to use this. This works well. Doing the mouse in front of the right. So here what we're doing is we're rotating first and then translating the origin. Okay, so how do I make sense of this? This is, by the way, this is 0 degrees. Node right here. The mouse is aligned with the left. So if I put it at something like 45 or 30 or whatever this is, what we're doing is we're rotating. Okay, we're rotating 30 degrees and then translating in this new coordinate frame, right? Where it's a slightly tilted coordinate frame. We've tilted, imagine like the grid, like that, everything's tilted. So now our x-axis is this way and our y-axis is like kind of like off to the side. So if I translate half of the screen and then half of the screen that way, we're going to be in this spot that's not half the screen. So as I'm like saying this out, this makes sense to me. I'm sure that maybe it makes sense to you too. Maybe you're kind of catching up still. I'm gonna just for a moment do this as I promised. I'm gonna do them in the opposite order. So now comes the translate and then the rotate, and we'll see that this is gonna have that more of that getting closer to that effect that I was going for. So okay, so if I was looking at the code here, explaining this one out, we're looking at so first the world has been translated. Translate the origin from here to here. Again, this is where the origin is. So when we say rotate, we're rotating around that origin. The origin has been moved. The origin is the center of the screen. Okay. So this works great. Okay. So this is, if I was going to say, I need to make an image show up in the center of the screen and it rotates around that center, this is how I would build that, and it rotates around the center command, like just that part, if I need to make it rotate around the center of the screen. Move the origin to the center and then apply your rotation. And that will draw this image at the top left of the image at the center of the screen. And so we're approaching the same result but from backwards ends with these two, because here's what I'm added, this OF translate, here's the last translate, OF translate. And then this is I need to, if the image is being drawn, instead of the center, it's being drawn here, I want it to translate up in the negative and the negative y. So negative, here's our command up here that we're copying in, negative 430, negative 209. Okay, we just built back the same lines of code that are sitting up there. We just did it in the reverse order to kind of help clarify. I feel like, you know, it's gonna take a bit of playing to just understand, to get really familiar with this. I will frequently like put transforms in the wrong order. The cool thing about it is it's just one run and you realize two lines need to be flipped, and it's a real quick fix. So you can it's almost quicker to test. Just test it and then try it. Okay. Should we do a scaling real fast? OF scale. Here's the thing: is the origin is still 1, 1. This is going to scale it. This is no transform. Scaling of 1 means 100%. 100% in the x, 100% in the y. That means no change. If I said 0.5 in the x, 1 in the y. Let's do this. Yeah, let's do it like this. Let's make him really like thin, like in the squished. He's like going through a wormhole or something. Okay, so what I'm going to do is I'm going to scale. This is my goal here is I'm scaling in the y only. Okay, this is fine. It's just now, do you see that he's not translating around, or he's not rotating around his center anymore? It's still the center of the screen. It's just the scaling. Now what I'm suspecting is the order is a little bit out of place. What we're dealing with is, and then here's what you can think about it. It's probably helpful to think about from the image's perspective, which means you sort of go backwards, up and out from the matrix. Oh, I haven't even said what that is yet. Okay, anyway, what we're doing is we're drawing at 0, 0. This is the image perspective. He's being drawn at the origin. Then we do this scale, and the scaling. Where does the scaling happen? The scaling happens from the origin, right? The origin is the image is being drawn at the origin, top left corner, right? And then the scaling happens like this. So suddenly now our image is shrunken in the height. It's no longer 418 pixels tall, so that this translate right here that we're doing, it's no longer 400. This is no longer the half of that value. So what we can do is, so remember this scaling is happening from the origin. We're doing a bunch of this translate, rotate, and stuff. This is all happening from the origin too. If I move this here, so that first we do this translate, so that the center of the image is now at the origin, and we say now scale from this origin. We're scaling in, imagine first it moves to the origin, then the image is squished like that. Okay, so the center of the origin is still at the center of this image. Do you see what I'm doing? I'm going from the image's perspective back out. which is different from the world's perspective towards the image, like thinking about where the origin is. World perspective, you read like this way. Here's me moving the origin, here's moving the origin, and the image is being drawn at the origin. If I'm just thinking about from the image's perspective, it's at the origin, so this is how I was able to solve just the order of these two things. If I first scale it, it's going to be, shrunken in the y. If I move it so that the origin is at the center first, and then if I think, right, because the origin's at the center of this image, if I do any kind of stretching, scaling, rotating after that, once I've moved the image to the center, it's still going to be at the center. That's the unique thing about translations, is that they're the only ones that move the origin. All the other ones, you don't have to worry about that. And this is it. So this is scale, translate. I've shown you about scale. Normally I would do this like, maybe I would do it like, here's what I would do. Normally I would do this kind of thing where I scale evenly, right? So we're not distorting. It's not going through a wormhole. Okay. Yeah, there it is. Okay, so this looks like, okay, maybe I'm making a game where I'm trying to fire the lasers. He's got a laser. Fire the laser at certain things. Doesn't do anything. Okay, so so to wrap up the video, we're not quite there yet. We just need to actually this is a kind of a big thing we need to deal with. How do we draw? Like let's say I've got OF, like another image. Let's say I got asteroids flying by him or something. I'm gonna draw just a gray circle. OF draw circle, and I've got this circle. Can we just animate it going in from the? Let's see if can I build an animated OF draw circle. The Y position is like a fourth of the way down the screen, something like 150 pixels. Radius is 20. OF set color 127. Okay, I'm gonna set this to be white up here so I undo my changes. Okay, so I'm just drawing a circle. I want to do is animate this so that it goes. Can I do this? OF. I guess I can just do the asteroid position. This will be one more variable. Float x. X is equal to OF get width x, and then every time we draw it, we do x equals x minus 10. Let's make it go kind of fast. Wait, that might be too fast. 5, something like this. And then if x is less than 0, here, this just keeps it in our screen. Okay, right? X is equal to of get width. Okay. What the whole point of this is I've commented it out. So I'm just trying to draw something else on the screen here. What we're going to notice is that when we do these transforms, we're changing the entire world around us. So we're going to notice that it's going to affect things like this. Watch, when I pull this all back here. Now that I've drawn this, and then here's this asteroid, it's going to come. I reset my color. I'm doing all that stuff fine. It's just that, do you see, like, as I rotate, do you see what happened? It not only like the asteroid is like rotating along with us. It's getting all the transforms. It's getting the scale as well. Yeah. So there's a real easy fix. It's really nice, and maybe I can just type. Let me show you the code. How the code looks real fast. So if I say before any transform happens, it's like I want to ask the computer, before we do anything, can you just remember how you are? Remember the state that you're in right now. OF push matrix. Push matrix is like saying, remember how remember your current transform. That's kind of like a bit more appropriate. Remember your current transform. It's like everything from here on is going to happen. You know what? Here's a better way of saying that. Everything from all transforms after here happen on a new layer. Okay, it's not too like this. I think this is an appropriate way of thinking about it, and it has this like sort of analogy to like how Photoshop works. When you're doing your work, you can at any time you can create a new layer, and now anything that you're drawing is happening inside of this new layer. It's not affecting anything down here. And what you can do is at any time you can delete this layer, move it somewhere else or whatever, and just nothing has changed under here. So I say remember your current I almost really like this one better. All transforms here on will happen on a new layer. Okay, and where do we want this new layer to end? We want all these transforms to apply to this image. Once the image is drawn, we don't need those transforms anymore, right? So at this point, we don't need those transforms anymore. And then we do, so OF pop matrix is the same but opposite operation for this. Push on a matrix, pop a matrix. Push on a matrix, it stores however the world was, and then when we call pop, return to the state you were, return to the state that the world was before we call push matrix. So it's almost like all of that doesn't matter, and when by the time we get to here, it won't inherit any of the transforms that happened in between the push and the pop matrix. It's a way of like isolating the transforms. There we are. Yeah, great. Right. Okay, so I wonder if there's any questions right now. So one thing I do in my code, just to clean it up a little bit, I've seen this before in C++, in OpenGL code. Once you have a push matrix, just tab everything in pop matrix. Not many people do that. So, I take that one, don't listen to me, whatever. Try it out. If you don't like it, just leave everything like this. But what this does is it's kind of nice because it helps me keep track of like where I am in the matrix stack. And when I say matrix stacks, I mean that because we could say OF scale 0.5 because we realized, wait, I just realized everything needs to be smaller because maybe maybe our screen is not our screen is too big, like something with the screen size. Everything needs to be smaller. So if I do this scale, then do you see how the ball got smaller there? And it's also the entire window size scale. So when I say OF get width, remember how the ball is being reset to the OF get width position? Even the OF get width, it's still returning the number 1024, but because that world has been scaled down, 1024 now only counts for half of the distance that it once did because we've scaled everything. So what we can, if we've done this scale, do you see how it works fine? We've done a scale and then we push the matrix. So all those changes are happening here. When we do the pop, we come back to where we were, was with that scale, right? So we're inheriting the scale down here. The scale still applies, the top scale, right? This push matrix, pop matrix can be done, watch, I'm going to layer another one in. Push matrix right here, of pop matrix here, and what we've done is we've isolated that scale. So the push and pop combination can happen as many of them as you want. There's very little cost to using them as far as like slowing. Ooh, now it's just barely. Ooh, that's a close call. Okay. there's like, think of them as like there's no cost. You can put as many push and pop matrices. You got to keep track of them. That does get challenging. Make sure that you're actually popping when you push. But this is like, it's tapping into a very low level OpenGL thing. So you're good. Like these are like, when you're using these, you're speaking the computer's language. It's like very happy that you're using push matrix and scales and translates and stuff. So yeah, very little cost will incur. Unlike drawing images, rendering videos, those are more of the costly type of things. So, okay, in this video we learned about using translate, rotate, scale, isolating the and learning about how that's actually transforming the origin. But then learning how to isolate those transforms to be this, they just happen in this localized little bit of code here. And I'm seeing right now, I can, what I can do is if I'm feeling like I can move things in and out of, like, right, I have a translate, a rotate, and a scale, and a translate. Maybe it makes sense to like group the image and its translate inside of a push matrix, OF push matrix, right? And then OF pop matrix here, so that this image is being like it's being centered on its own, and I can sort of consider this code for just like centering the image, and I don't have to worry about like having it in the same like line of codes as these other OF push matrices and pop matrices and stuff. Okay, so yeah, you can kind of group your, kind of helps you like organize your transforms like that. Okay, I think this about wraps up what I was going to do. Transforms, okay, yeah. Okay, good. All right, thanks.